Good morning, students. Hope you have done Kirchhoff's law properly. Then Wheatstone bridge also we had talked about. Now the next topic we are going to take up is meter bridge. This is the practical application of Wheatstone bridge. In the Wheatstone bridge, we had 4 resistors arranged in such a manner that the balanced condition came out to be this. If we quickly review what we did in the Wheatstone bridge, is this. We had R1, right? We can consider this also R1, R2, R3, R4, right? So for balanced Wheatstone bridge, when we say balanced Wheatstone bridge, that means galvanometer would show 0 deflection. That is the concept of null deflection. The same concept we are going to use in meter bridge, and the balance condition is this, right? R1 by R2 equals R3 by R4. In a very similar fashion, we are going to take up this one, okay? Meter bridge. So here we have a thick metal strip, right? And 1 meter wire is connected at the 2 ends, of this metal strip, right? Now there are 2 gaps in the strip that you can see. In the 2 gaps, 2 resistors R and S are connected. One of the resistors has got the known resistance value and one has unknown value. So with this device, we are going to determine the unknown resistance, determine the value of unknown resistance. Is that clear? So one end of the galvanometer is connected to this point B, you can see, right at the middle of the thick metal strip, and another end is movable. It is joined with jockey, right? Connected with jockey. Jockey is nothing but sort of metal hook that can be it is sliding. You can slide that jockey on this wire, and where the galvanometer shows 0 deflection, that point is called null point. And then what we do, we measure the balancing length. We measure the balancing length. This L1 we can consider here. L1 is the balancing length, or L, whatever. From end A, we are measuring this length of this balancing, length of this null point from point A, right? Null point. At this point D, you can see on the diagram, galvanometer shows 0 deflection. One very interesting fact, you must ask that in Wheatstone bridge, there were 4 resistors. Here we are not considering 4 resistors. Actually we are considering there are 4 resistors. How come? I tell you. This wire has got, this wire of 1 meter uniform cross section, 1 meter length and uniform cross section, has got the resistance, right? We may call the resistance per unit length. This is phi, this is resistance per unit length, and length is measured in centimeter. That is important here. Okay, so when we have resistance per unit length, phi, so what we can do, if we apply that logic, Wheatstone bridge, balanced condition of Wheatstone bridge, what we can do is, we have R by S. This upon this equals resistance of this, you can see arm AD, right, and DC. These two are also having some resistance. What is that value of resistance? It is very simple, I tell you. Phi into L. What is this phi? phi is resistance per unit length. When we have multiplied resistance per unit length with length, we got the value of resistance of this segment of the wire, right? This segment of the wire. Furthermore, what we will have, this upon 100 minus L into phi, right? So we got this, and what is going to happen now? This phi values, being the same value, this will be cancelled. So finally we are going to have this R by S equals L by 100 minus L. So this is the basic concept. Now what we are going to do, we have unknown resistance value S that we can determine. How we can determine? Like this, S equals 100 minus L divided by L into R, right? R has a known value that we can determine. R has known value, that unknown value of resistance S can be found using this expression, right? L here is called balancing length. What is this L here? L is balancing length. L is balancing length. When we say balancing length, what we are actually saying is that this is the length of the wire from end A where galvanometer shows null deflection, right? And if we treat this arrangement as the balance condition of Wheatstone bridge, we can have this relation, and with the help of this we got this, right? We got this expression. Unknown value of resistance can be easily determined, balancing length. Okay, very interesting fact. If I ask you very simple, that logic you need to apply here. If you interchange this R value and S value, what is going to happen? Can you tell me? Do you think that same null point we are going to obtain at D only? Same null deflection you will obtain at length L1 here? No, that is not possible. I tell you why. Suppose R value, I tell you why. Just have a look. If you have got R equals 5 ohm and S, I don't know, that might be some value. So I'm taking it just for the sake of understanding how interchanging the value of resistance in the two gaps, interchanging the resistors in the two gaps, how that can affect this relation, that we need to understand. Okay, that is very important. So suppose we have value say 7 ohm, right? If you are putting as R by S, then you have balancing length L1, so it is going to be 100 minus L1, right? If you interchange the value, so if you interchange the value, then what will happen? S by R, if you do this, then what? Then this balancing length will, this null deflection will not be obtained at this point D. It will happen at some other point. It will happen at some other point that we need to understand, right? So if we interchange, so look at it, 7 by 5, suppose we got it, 7 by 5 is not equal to 5 by 7. Is that clear? Is that really easy for you to understand? 7 by 5, in this case it is going to, in this case it is 7 by 5, okay. In this case it is 7 by 5. In this case it is going to be 5 by 7. So do you think that 5 by 7 and 7 by 5 are same? No, this balancing length L1 will be different than the L2 value. So here I am going to put it L2 by 100 minus L2, right? That we need to understand. Condition would remain same. Mind it, in the Wheatstone bridge concept, we talked about if we interchange the galvanometer battery arm, right? The resistance values also, if you interchange, then condition has to be same, right? Condition has to be same. In this condition, we are taking up R by S equals, then this null deflection will show at some point, right? If we change this here, if it becomes, as we have taken the value, we had taken the value 7 by 5 in this case. So if we change the value, if we interchange the resistors in the gap, then null deflection will be at different point, and the balancing length will be different, right? This is a very important result, conclusion, that can be widely used, that can be asked in various competitive exams, be it JEE or Neet. So be very careful. You need to be very careful, right? Okay. So till now we have understood the very basic concept. Why don't we do one thing? Let us take a few numerical examples, questions, right? So let's talk about this. So here, this is NCERT question. Just have a look. What has been given to us? What has been given to us? In a meter bridge, null point is found at a distance of 33.7 centimeter from A. If now a resistance of 12 ohm is connected in parallel with S, the null point occurs at this. Determine the values of R and S. How many unknowns are there? 2 unknowns are there, right? Value of R and value of S we need to determine, right? Now what? We need to have 2 equations. 2 unknowns, 2 equations. That is simple logic, right? So, and there are 2 situations. When condition is this, when R and S value were taken, L1 was the balancing length. That value we have as L1 equals what? 33.7 centimeter. Minded, this unit we need to, keep in mind. Okay, this unit also. Because at times, they might give you in terms of meters, right? 0.337 or something. So we need to be careful about the unit also, because in numerical examples, in numerical problems, many students make mistake while dealing with the units. So be careful with the units, right? Okay. Now, if this was the L1, right? Now if we change, what do we change? We have connected another resistor of 12 ohm, in parallel with S. This is the condition. Then do you think that balancing length will be same? No, that is not going to be same. That will be different. Why it would be different? Because R by this value, this equivalent value of resistance connected in this gap has to be taken. So this is very important aspect in this question. You have to be careful, right? They might give you different situations. It is not necessary that this S value is connected in series or parallel with some other resistor. They might change the value, right? Situation 1, it is normal situation when no other external resistance connected across any of the 2 resistors, right? Rather what? Rather, that is situation 1 where nothing is connected. Additional resistors are not connected. And situation 2 when external resistors are connected, they can switch the condition. They can connect it in series or parallel. So what you need to take into account is, whatever, if it is there, you consider a single value, single equivalent value of resistance, right? After you have connected this, you have to consider this equivalent value of resistor across this. If external, some other additional resistor is connected in series or parallel, whatever, here in this case it is connected in parallel with S, that we need to take into account as the R equivalent, right? R equivalent, sorry, here it is S equivalent. Oh, there is a, okay, so this is S equivalent, because S, it is connected with S, so it is S equivalent, right? This is S equivalent. So this is actually R by S equals, case 1, R by S equals L1 upon 100 minus L1. Mind it, when no additional resistor was connected, balancing length was L1. So in that scenario, R by S equals L1 by 100 minus L1, right? Now, what we are going to take into account, this S equivalent. Why S equivalent we are going to take up? Because this single resistance we need to consider equivalent, obviously, equivalent. So it is not, it is this actually, this is R by S equivalent equals, then balancing length is L2, balancing length would become L2, right? This null point is obtained as at this 51.9 centimeter. This is different value. So L2 by 100 minus L2. Right? 100 minus L2. So this is what we need to consider. Okay, now what? Now what? Just have a look. This thing. We have equation 1, R by S equals L1 by 100 minus L1. This is equation 1. And then we have R by S equivalent equals L2 by 100 minus L2. Right? It is connected with S. 12 ohm resistor is connected in parallel with S. So this we are going to take up. These are the two equations, right? L1 value is, L1 equals 33.7 centimeter. L2 value is 50, what was that? Let us, okay, 51.9 centimeter, 51.9 centimeter, right? So, is that easy? Yes. What is S equivalent here? So, let us have a look. S equivalent, 12 ohm and S are connected in parallel. So, what is the value of S equivalent? S equivalent we can have as 12 S by 12 plus S. So this is the value. So if we substitute this value, what it is going to be? It is going to be R by, it is R by 12 S, and it will go up 12 plus S. This equation is going to be equation 2. So this is again L2 by 100 minus L2. So this is equation 2, right? So solve this. Solve this. Right? So if you have this equation, these two equations, substituting these values, just solve this. Is that easy? Yes, it is. Finding out the value of R and S would be just a calculation, just mathematics. So problem is solved, right? Problem is solved because that is calculation. That is easy, for you to do. Okay. Now let us take up another question where we have some different situation. Let us take that question. Now, question number 2. This one is easy, no? This one is easy. This one is very easy. No additional resistor is connected. It is simple. Balance point is found to be at 39.5 centimeter from end A. When we say end A, that means, you know, this is end A, right? This is end A. This is end A, and this is the value of, okay, they have talked about this X, and they have talked about this as Y, right? Balance point is obtained at this L. This is very simple calculation, right? So this is the given situation. So L value is known to you. Y value has got, okay, we can consider this 12.5 ohm, 12.5 ohm, all right. X value, okay, determine balance point of the bridge. Determine the resistance of X, right? First is determine the value of X. So if you have this relation, what is this? X by Y. X by Y equals L by 100 minus L. So it is quite simple, no? It is quite simple. So just do this. Do this. Here only we can solve it. And this is very simple calculation. So take this up. X by Y equals, what is L? What is L? L is 39.5 divided by 100 minus 39.5, right? So this, and here you have value of Y as, value of Y is 12.5. So what you can do is simply, you know, X equals what? X equals 12.5 into 39.5 divided by 100 minus this. What is going to be? What is it going to be? 60.5, right? 60.5. Yes, this is going to be 60.5. Whatever it is, 60.5. So this is the value, this much ohm, right? So that we can do. Now the situation is different. In the next case, situation is different. Determine the balance point of the bridge. That bridge actually, if X and Y are interchanged. X and Y are interchanged. So what we are going to do? X and Y are interchanged. Okay, let me draw it once again to make it more clear to you. This here now, this is Y, and you have X value found here, you know, that X value you found. This is terminal A, this is X. So now you have L2 value here, and this L2 is to be determined, right? L2 is determined. This is 100 minus L2. So now the equation would be what? Now the equation would be Y by X equals L2 by 100 minus L2. 100 minus L2, right? 100 minus L2. So we have value of Y, we have value of X, because we determined the value of resistance X. So that value we will put here, and we solve this for this value L2, that we can determine, right? That we can determine value of L2, right? So this was the question. If you interchange, then make sure that this comes out in this manner. Y by X. Earlier it was X here and Y here. I have interchanged it as per the given question. Now it is Y by X, and then balancing length is different, L2, right? That we did. Okay. In the next question, that calculation you can do because value of y is known to you, value of x you determine here in the first part of the question, and then put these two values are known to you. This value unknown value of L2 can be found. Unknown value of L2 can be found, right? So let us move further. Now this is the question. Two resistances are connected in the two gaps of a meter bridge. Okay, fine. The balance point is 20 centimeter from the zero end. From the zero end means end A. I must draw it again. So just have a look. This is end. This is end A. This is end A, right? And this is another gap. Okay, this is end B. Galvanometer here. Okay, what is being there? This L1. Okay, let me call this L1, which is equal to L1 equals 20 centimeter, right? This is given to you. Zero end. A resistance of 15 ohm is connected in series with the smaller value of 2. We don't know what is the smaller, which one is the smaller value. Okay, so what we can do is, let us call this R, this as S. Think of it, just assume that okay, S value is smaller, R is greater than S, that we have assumed. Okay, so it will not make any difference, because when you assume according to that assumption, you are going to consider the shift and all other balancing length values, so it will not make much difference. So now value S is small, so that S value you are supposed to find out. Okay, so let us have a look what happens when you connect. Mind it, when this was the condition, then you had this relation, right? So it was this R by S. R by S equals, L is 20 centimeters, so let's put this as this 20 upon 100 minus 20, that means I'm straightforward putting it here. So this is what do you call, this is 80. Okay, that means 1 by 4. So we don't know which one has got what value. Here we have smaller value, as you can see that S equals 4R, right? S equals R4. So what happened here? Assumption gone wrong. So what we need to do, we consider that okay, R is smaller value, R is small value. Okay, R is smaller, right? So S value is this we got, this we have understood. Now what happens? Now the second condition is smaller value is R. Now there is another 15 ohm resistor is connected in series with R, because R here is a smaller value. So in that situation, R equivalent, that is R plus 15, R plus 15 divided by S, S remains same. Then what? Then what? The null point shifts to 40 centimeter. Earlier it was at 20 centimeter. Now it is at, when it shifts towards this end, if it shifts towards this end, now this is 20 plus 40. So null deflection is obtained at 60. So what you will have? 60 upon 100 minus 60, that is 40, right? So this you have. So further, just note down this thing. Just note down. So S value is 4R, that you will put here, right? Smaller value you are supposed to find out. So this is what? 3 by 4. This is 3 by 4. Okay, so let us find it out. R value you are supposed to find out, right? So it is R plus 15 by 4R equals 3 by 4. So this 4 gets cancelled. So further, this is 3R equals R plus 15, right? So where we went wrong? So calculation would be like this: R by S equals 20 by 80, that we found. S equals 4R, that I have put here, and then R plus 15 we have taken up. Then we have to solve it. We have to solve it. It is going to be what? Let us take this 3R. This 3R equals R plus 15. 3R equals R plus 15. So this we have to take into account actually. So value of R we need to find out, right? Value of R we need to find out. R value we need to find out. So this calculation, simple calculation, right? And many more questions based on this potentiometer, based on meter bridge, we have to do. We have done Wheatstone bridge, we have done meter bridge. Now in the next session, we will talk about potentiometer. That is another electrical instrument which is used to determine the potential difference, right? Another electrical instrument that is used to measure potential difference accurately, right? There is voltmeter, but there is potentiometer that measures accurately. Accuracy is better in potentiometer. That we will do in the next session. Okay, thanks a lot. See you in the next session.